Okay guys, let's pick up from where we left off here on the Unit 1 test review, and I'm going to just go straight to your packet and do a few questions, okay? So let's take a look at it here. Let's just a quick review from where I left off on my last video. This is just a continuation from the last video. So I was graphing, I ran out of storage space in my flash drive, but I was graphing this right here, this exponential function. Let's just review really quick. It says y equals 2 to the power of x minus 1. I always like to put parentheses in these ones right here. So I know the exponent is x minus 1. Whatever we do to the x is our h value. And it doesn't have anything here. There's nothing outside here, so there's no k value. So I always extract my h comma k, which marks a very important point in my asymptote. So the opposite of -1 is 1, and there's nothing here, so it's 0. Like plus a 0, I can assume that it's plus a 0, so that's a 0. That marks my h and my k value. It's a very critical point in my asymptote. The asymptote is actually the line y equals 0. It's always the k value, okay? It's always the k value, y equals the k value. That is our asymptote. But there's this critical point here, which is the h and k, 1 comma 0. If you plug in a 1 into this graph, I guarantee you, with all my mathematics assurance, that you're not going to get a 0. So that's why it's an open circle right here. If you plug in a 1 for x value here, 1 minus 1 is 0, but 2 to the 0 gives you a 1. And that's why the very first point on my graph is a 1 comma 1. It's always the point right above the critical value here of my asymptote, okay? Then you come back to your asymptote here. You got your first point, you got your asymptote, you got that critical point, you got your very first point on the graph. You come back to your asymptote and you count the base. The base says, the base is a 2. So from here I'm going to count up 1, 2 over 1. And that is my second point on my graph. So now I have all the important pieces of this graph. I have the asymptote, I have my first point, my second point. I know the general shape of an exponential is always kind of like a J shape. And here we go. Okay? So the technique is always identify the asymptote, which is y equals k value, that important point, the open circle, and then count the base from there. Okay? So I'm pretty sure you will be able to do the same exact thing here for this exponential. All right, I like to put parentheses here so I can find my h comma k value. Okay, it's opposite of h, same as k, and then you're going to mark your asymptote and you're going to count the base. So I want you to do this question by yourself. I'm going to put a little star next to it, and come and show it to me. If you want to just show it to me in class when I'm coming around checking homework, just show it to me to make sure you graphed it correctly. Okay, all right. Let's do another question. Let's do number 21. Let's work on number 21 here. Number 21 says, evaluate, but is giving us instructions, evaluate, but do not graph. They're not asking us to graph. They give us the function, if the function f of x equals, there's two options here. I like to label that one option A, and I like to label this one option B. So there's two functions going on. This is a piecewise defined function. We define the domain for you. For x's that are less than -1, you're supposed to use this function right here to graph this function. And if for x's that are greater than or equal to -1, you're going to use this function over here or graph this function. In this case, they're not asking us to graph it. They're just asking us to evaluate. So I don't know if you remember from a previous video, whenever they ask me to evaluate any value of for x, I like to create a number line to create my decision rule. So for evaluating, evaluate, I like to create a decision line. Here's 0, 1, 2, and 3, all the way to positive infinity. and then -1, -2, -3, all the way to negative infinity. So I have this number line, and I like to organize my thoughts here. If I am picking any value that is x's that are less than -1, right here, anything that's less than -1 in this direction, I am going to use the function a here, the top function, function a. If I am evaluating any x value that is greater than or equal to -1, so equal to -1 or greater, we're going to choose function b, okay, the second function. So now I have an idea of where, you know, if whatever x value you're using, which function I'm going to use. So they asked me to start with evaluating a f of 2. So I take a look at my number line here, and I say 2 is greater than -1, is right here. I'm going to be using my function b. So I come over here and I see the function b is 3 to the x plus 2 power minus a 4. So 3, instead of an x, we're going to use a 2, and then plus a 2, which is part of my function, and then subtract a 4. Okay? So that's a 3, 2 plus 2 is 4, minus a 4. And 3 to the 4th power is 81. So 81 minus a 4, which equals 77. Okay? So when I plugged in a 2, we got a 77 for y. So the answer for here is, when you plug in a 2, you get a 77. Okay? Let's do another one here. Let's see what happens when I plug in a -2. So let me see if there's room here. Let me move things up a little bit. When I plug in a f of -2, okay? All right, so -2 is here, is less than -1, so I'm going to pick my function a, all right? So in function a here is 3 minus 2 times the absolute value. Instead of x, we're plugging in a -2 plus a 5, all right? So now I'm carefully going to evaluate this to see what we get out for our answer. Okay, so 3 minus 2 times the absolute value, we have -2 plus a 5, which is a positive 3, okay? Which equals 3 subtract minus 2 times the absolute value of 3 is 3, okay? And then this equals 3 minus 2 times 3 is 6. So we have a positive 3 minus a 6, which is a -3. So when you plugged in a -2 in this function, we got out a -3. Okay? So that is my answer right here. We were looking for this, and that's where what's going to go right here, -3. Okay? So that's what evaluating is. It's not asking us to graph it. It's just getting used to evaluating, because evaluating is such an important skill to be able to graph piecewise functions. As a matter of fact, I have a student that requested, Mrs. Myers, can you please do some piecewise functions graphing? And that's what's coming next here in the questions I want to work on this video. Okay? So this one is saying, graph each of the following, and then, very important, identify the domain and range in interval notation. Okay, they want us to use interval notation. So immediately I got to remember those rules. Open means I'm going to use parentheses, and anything that's closed or include, I'm going to use bracket. Okay, so something that is included, it's closed. Something that is not included, open, I'm going to use parentheses. That's what interval notation rules, the interval notation rules are. All right, so let's take a look at this function right here. I don't like this tiny little space. I'm one of those people that like lots and lots of room to work on things. So I'm going to move on to here. I'm going to use this white paper. So we have two functions. We have f of x equals there's two pieces. That's why it's called piecewise defined functions. We have this function over here, f of x equals 2, for all of the x values that are less than 0. And then we have f of x equals negative x plus 2 for all of the x values that are greater or equal to 0. What I like to do is I like to pull apart these pieces, okay? I like to separate. I'm going to do f of x equals 2 if I have x's that are less than 0. And then, once I'm done with that, I'll worry about the other piece, which is f of x equals negative x plus 2 for all if the values of x's that are greater or equal to 0. Okay? So I like to worry about graphing one function first, and then I'll pick up right from where I left off and graph the other function. Okay? So now I'm going to use this little graph over here and leave some room on the bottom here to work on. So x is less than 0 right here, only on this side of the domain. That's where I'm going to be graphing this function. Immediately I see this and I know this is y equals a constant. That means it's a horizontal line. Okay? So let's go to y equals 2, 1, 2, right here. And I'm only allowed to go to x's that are less than. I'm only allowed to go to the left of 0. So I'm going to be graphing in this direction. There we go. But let's see what happens. We always have to evaluate what happens when I plug in 0 for x. Well, we get a 2 for y. So 0, 2 is a very important point. 0 for x, 2 for y. Because is not included, I have an open circle at the end of this graph. So I'm supposed to put an open circle right here. Okay? So I'm done. I graphed this top function right here. Check. I'm done with that one. Now let's move on to the other function, which is the second part. I have for some people don't like f of x. It is the more advanced way to show a function. But some people like to see y equals mx plus b. Here's your slope, and here's your y-intercept. Okay? So there's your slope right there, and there is your y-intercept. All right? So I know that I'm supposed to go to a y, the y equals 2 value here. So, and I'm supposed to have a closed dot for 0. So at y equals 2, I'm going to put a closed dot. And remember, I mentioned in class, a closed dot overrides an open. Okay, so a closed dot overrides an open. We had it open at first, but then I came in and I put a closed one on top. So it overrides. There's my y-intercept, and the slope is drop 1, run 1. So from here on my graph, I drop 1, run 1, drop 1, run 1, and drop 1, run 1 forever here, going for any x values that are greater than 0. So our graph looks like this. It took a turn to a totally different type of function. Okay? So it started as y equals 2, and then it changed it to a totally different linear. But now I took care of both. I graphed both of them, and we're done. They ask us to identify the domain. I love to just come to the domain and say, well, didn't the domain already existed here? It said all the x values that are less than 0, and include 0 on this one over here, and all the x values that are greater than 0. So for anything that's less here, on negative infinity, it's going to be part of my y equals 2, and anything that's greater than 0 to the positive infinity is going to be part of my function negative x plus 2. So this is all real numbers. So you can use the symbol for all real numbers to show me that is the domain, or you can write all real numbers. Okay? Either way, I accept it for you to show me all real numbers. But they want us to use an interval notation. I just realized that. An interval notation, we got to show it with from negative infinity to positive infinity. So that is the interval notation we're supposed to use here. Okay? All right, now for the range. okay? For the range, we look at the y values. The y values I see here, so we're focusing on the y-axis. The highest y value we are going to see here is y equals 2. There's nothing graphed above here. It's from here down that we're heading with all the values. So the highest value is a 2, the lowest value is negative infinity. We always put it from lowest to highest. So it's going to be from negative infinity all the way up to a 2. Including the 2, it's closed, so we put a bracket. Okay? So that's how we show in interval notation the domain and range for this function, for this piecewise function. The domain always comes from here. We already explained in the function, there's already explained the domain. Okay? All right, so let's do one more so we can get this understanding a little bit more of piecewise function. Let's go ahead and do this one. It's an interesting one because we have a parabola. I can see that squared right there tells me it's a parabola. And then we have an absolute value. So it's a very interesting two pieces of the function, these two functions. I like it. So let's go ahead and separate it into two. I like separating into two and then kind of like getting my thoughts straight here. We have f of x equals x minus 1 squared. That's a parabola. It's going to face up because our stretch here, our leading number here, is a positive one. So I know I'm supposed to be graphing a open up parabola. Probably just a part of it, not the whole thing. And then this is only for x's that are less than 3, not including, so I know I'm going to have an open circle right there. And then when I'm done graphing this one, I'm going to switch and I am going to go to f of x equals the absolute value of x minus a 1. Okay? And that is for all the x values that are greater than 3. So when I look at my x-axis, half of it, here's 1, 2, 3. There's a point right here. So anything that's less than 3, I should be seeing a parabola. And then if I cover it, anything that's greater than 3, I should be seeing a piece of an absolute value somehow. Okay? So let's tackle the parabola first. Okay? All right, so the first thing I look in a parabola is what is my vertex? That's the first thing. We always take it from a parabola. It is opposite of h, right here, opposite of h, which is number 1, same as k. There is no k value here, so it must be 0. Okay? And then I look at my vertex. Is my vertex in the area that I am allowed to graph? 1, 0, which is right here. Yep, it is. This is less than 3, so I'm safe. I'm going to go ahead and put my vertex because 3 is right here. Okay? That's 3. So it is on the side that I can graph. And then I look at my stretch. The stretch is just a 1. There's an invisible 1 right here. So I'm supposed to go up 1, run 1 to both sides because parabolas are symmetrical. So I'm supposed to be opening up in this direction and that direction right here. But it's very, very important to see what happens at a critical point of 3, because that's my domain restriction here. What happened when we plug in a 3 into this function? Again, we're evaluating. So when I plug in a 3 minus 1, and then you square it. 3 minus 1 is 2, and then you square it. And 2 squared is 4. So at x equals 3, we have a value of y equals 4. And that is supposed to be an open circle. So at 3, we're going to go up to 1, 2, 3, 4. There we go, open circle, finish my parabola. So there we go, I finished the parabola. Okay? And I am done with this function. Let me check mark it. Done. Now let's move on to the other function, which is the absolute value. So remember, absolute values look like a V shape, and it points up because our slope here is 1. So I know I'm supposed to have some sort of a piece of an absolute value. Okay? Let's take a look at the starting point or the vertex for this for this absolute value. It looks like is at opposite of h. There is no h value, so that must be a 0. And same as k, there you go. 0, negative 1. That's my starting point of my absolute value. But 0 for x and negative 1 for y is in the area that I'm not supposed to be graphing. I already have a parabola graph there. So the starting point really doesn't help me much here, okay? If it was the starting point on the place where I could, anything that's greater than 3, I would be okay, but it's not. So the next thing I should do is worry about my critical point. What happens when we plug in a 3, just like the domain restriction tells me here? What happens when I plug in a 3 into my second function over here? The absolute value of 3 minus a 1. Okay, what happens? The absolute value of 3 is 3 minus a 1. 3 minus 1 is a 2. So we have a very important point, 3, 2. Whoops, there's my paper. So we have 3, 2. And that is also an open circle because it does not include the 3. So I'm going to come back over here and I'm going to go to 3 for x, 1, 2 for y. And there's my open circle. Okay? I'm trying to go from here, I'm trying to create my absolute value function. And then you look at the slope of this absolute value. It says 1. So I can rise 1, run 1, and continue graphing my absolute value. Rise 1, run 1, rise 1, run 1. If you want to make sure that you are correct, what happens when you plug in an x equals 4 into my function? And you can evaluate. The absolute value of 4 is 4, and then you subtract 1, you get 3. So I should be at 4, 3, 4, 1, 2, 3. Yep, that's correct. I am graphing in the correct direction. And that finishes my graph of the absolute value. Okay? If you imagine the rest of the absolute value should be coming down here to that starting point, if just the invisible part of it would be coming down here and going in this direction. So yes, you are graphing it correctly. Okay? And that is how you graph piecewise functions. You have to worry about one function first and then worry about the other. Now let's talk about the domain and then let's talk about the range. Okay? The domain are the x values. So if you look here, let's look at what they're saying here. They're saying you can graph all the x values that are less than 3 for this function, and then you can graph all the x values that are greater than 3, but does not include 3 anywhere here. So it looks like it's all real numbers, except we cannot include the 3. So from anything that's less than 3, the domain exists for my parabola function. So from negative infinity here on the x-axis all the way to a 3, I have my parabola. So from negative infinity all the way to a 3, open for, we use a parenthesis because it did not include the 3. And then we have a union from a 3 all the way to a positive infinity. We'll be graphing our absolute value. So from 3 to positive infinity, and we use parentheses. So there you go. That would be our domain in interval notation for this graph. From negative infinity to a 3, we're graphing our parabola, and from 3 to a positive infinity, we're graphing our absolute value. And I didn't include the 3, that's why I'm using parentheses, okay? Now the range, we look at the y-axis. Okay, here's negative infinity, and here's positive infinity. So it looks like the y value, the smallest y value we have in that's part of a graph would be 0 for y right here. Okay? So it would be from 0 for y, including it. So let me put a bracket. And it looks like we're going all the way to positive infinity. In either graphs, we're heading to positive infinity. So we would go to positive infinity, and that would be our range. Okay? Some students ask me, Mrs. Myers, isn't it open over here for a 3? Yes, we did mention that right here for the domain value. How about for the range? Well, the range, the y value of 2, it might be open for a 3 here, but it's closed for other pieces of the graph. There's other parts in the graph that does get a y value of 2. So there's your domain and there's your range, okay? And that is the conclusion of this piecewise functions, examples of piecewise functions. All right, try the other ones. I am gonna save these other ones to do it in class with you guys. So, and then try it. I'm also gonna leave it as a challenge for you to try it and then come and show it to me or discuss it in class during warm-ups in class, okay? So I hope this helps. We'll continue reviewing and creating more videos. Okay guys, take care.